Hi, today we are talking about the number of solutions when we solve a multi-step equation. So far we've only seen when there's one solution, right? X equals a number, Y equals a number. Well, today we're going to discover that that's not always the case. First, we start with some bell work. We have to distribute negative 3 times A is negative 3A, and negative 3 times a positive 1 is negative 3 equals 27, and then add 3 to both sides and divide by negative 3 on both sides of the equal sign. Okay, here there's a b on both sides of the equal sign. We don't like that. Choose one of them to get rid of. It doesn't matter which one you choose, but I like to choose the smaller one. So the smaller one is a 4b. The opposite of a positive 4b is a minus 4b on both sides of our equal sign. 4b minus 4b is 0. Some people write the 0. I just cross it off. Now we have negative 8 equals 8b plus 8. And now it's a two-step equation. Subtract 8 on both sides, and then divide by 8. That's a whole lot of 8s. Our goal, I can determine the number of solutions in an equation. So first, just a reminder of how to solve equations that we already took notes on. Simplify each side of the equal sign. So like one side, simplify that. Do all the distributing, do all the combining like terms. Then on the other side, simplify that. Do all the distributing, do all the combining like terms. Then, if there's a variable on both sides, so if there's an x on both sides or a y on both sides, choose one of them to get rid of. It doesn't matter which one you choose, but I always choose the smaller one. And you do the opposite operation. So if it's like a positive 4x, do a minus 4x. Or if it's like a negative 3y, do a positive 3y. That gets rid of it on this side, but then you also have to do that same thing on the other side of the equal sign as well. Then you just have a two-step equation to solve. So let's just take a look. I'm going to draw my wall. That's going to keep me organized. And one solution means I'm going to get x equals a number. First, I'm going to simplify this side. Negative 2 times 1 is negative 2. Negative 2 times negative 5 is positive, because a negative times a negative is a positive. 2 times 5 is 10 with an x next to it. Now this is a little tricky. There's an invisible 1 right here. So it's negative 1 times x is negative 1x, and negative 1 times positive 1 is negative 1. And then I also just write minus 1 at the end. It's not in the parentheses, so I don't distribute. So I did distribute on each side. Now I check if I can combine like terms. And on this side I can. It's a negative 1 minus 1. So now I have negative 1x minus 2 on this side. And on the other side it stays the same. There's nothing I can combine. Now there's an x on both sides. I don't like that. We have a 10x and we have a negative 1x. Negative 1x is smaller. The opposite of a negative 1 is a positive 1x on both sides of the equal sign. 10x plus 1x is 11x. I still have this minus 2 and then a plus symbol in front of that equals, and the only thing left over here, because a minus 1x plus 1x is 0, it's just the negative 2. Now it's a two-step equation. We want x by itself. We have minus 2 or a negative 2. The opposite of that is plus 2 on both sides of the equal sign. This one's fun. And so now we get 11x equals, well, negative 2 plus 2 is 0. Divide both sides by 11. 0 divided by 11 is just x equals 0. X equals 0 is a solution because 0 is a number. So we had one solution. There's one number that works. That number is 0. Now, sometimes when we solve, it's not going to say x equals a number. Let us look. We're going to work through this problem, and then I'll talk about what it means, and then it means infinite solutions, I guess. But we'll still talk about it. Okay, on the first side, there's nothing to simplify. It's just 2x plus 4. But on the second side, I can distribute. 2 times x is 2x, and a positive 2 times a positive 3 is a positive 6. And then I just write minus 2 at the end because it's not in the parentheses, so I do not distribute. On my first side, I can just write 2x plus 4 because there was nothing to combine. Now, on the second side, again, yes, I could combine my positive 6 and my minus 2. So I end up with 2x plus, well, 6 minus 2 is 4. Now, I'm going to pause right here. What do you notice about the two sides of my equal sign? They're the same thing, but maybe you get to this step and you don't notice that, and that's fine. We choose one of the x's to get rid of. Well, they're the same thing, so it's fine. And the opposite of a positive 2x is a negative 2x on both sides of the equal sign. Well, 2x minus 2x is 0. Like literally that means don't write anything here, and we just have 4. Equals, and again, 2x minus 2x, that's 0. We literally don't write anything here. We got rid of all of the x's. The only thing left over is a 4. This does not say x equals 4. This says 4 equals 4. And what that means is you can literally put any number in for x, and as long as you use the same number for the other x, it will work. So I could choose like the number 1. As long as I put a 1 here as well, it will work. I could choose a 10. As long as I put a 10 here, it will work. I could choose a negative 0.10. Negative 0.10. As long as I put them, both x's are the same number, then I will be able to correctly and successfully solve this equation, which means infinitely many solutions will work, or all real numbers. No, you don't get just get to choose a number. You have to actually say it's infinitely many solutions or all real numbers. Now, I prefer to write as few things as possible, so sometimes I just write the infinity symbol. Whenever it's infinitely many solutions, just here at the bottom, I'll just be like, boop, infinitely many solutions. That's how I'll write it. On ALEKS, I think they use the phrase all real numbers. Now, we've seen when x equals a number. We've seen when you solve it and you get a number equals itself. So it's true that 4 equals 4. That's true. That means that anything will work, all real numbers, infinitely many solutions. Now let's see what it looks like when we get no solution. So I'm going to draw my wall just to help me stay organized. There is nothing to simplify on the first side. And then on the second side, the 8 stays the same. A positive 3 times a negative z is a negative 3z. A positive 3 times a positive 4 is a positive 12. Now I can combine like terms, a positive 8 and a positive 12. I now have negative 3z plus 20. And then on the other side I have negative 3z plus 7. Notice how for my all real numbers, infinitely many solutions, it was exactly the same. 2x plus 4 equals 2x plus 4. Well, here it's negative 3z plus 7 equals negative 3z plus 20, so it's not exactly the same. So now there's a z on both sides. I don't like that, so I'm going to choose one to get rid of. Because they're the same, I can say I'm going to choose this one. The opposite of a negative 3z is a positive 3z. Excuse me, negative 3z plus 3z is 0. That means I don't write a z at all. I just literally have the number 7. And again, negative 3z plus 3z is 0. I don't write a z at all. I just have the number 20. But it is not true that 7 equals 20. That is not like last time. Last time it was true that 4 equals 4. That was true, so anything works. What happens when we have this means there is literally no number in the world that you could put right here and the same number right here and make this equation work out. Just nothing's going to work out. We call that no solution. Okay? So those are our 3 types of solutions. One solution, x equals a number. Infinitely many solutions, you get the exact same thing on both sides. Or no solution, you get a number equals a different number. So then you got in your notebook and you did page 34 in your notebook. Some of them would have been infinitely many solutions, some of them would have been no solutions, and some would have just been the same as normal, solving it and getting an answer. Then we do some whiteboard practice. I'm going to draw my wall. I'm just going to draw it as a straight line this time instead of a box. That's fine. 7 times 2 is 14. And then 7 times a positive 5v is a positive 35v equals, and there's nothing to simplify here. There's a v on both sides. I don't like that. We're going to choose one to get rid of. 3 is smaller than 35, so I'm going to get rid of the 3. It's a positive 3. The opposite of a positive 3 is a minus 3. So now that 14 stays the same. I have 14, 35, 34, 33, 32. Positive 32v equals 3v minus 3v is 0. So I don't have to write anything. I just have 14. Okay, subtract 14 on both sides. And I have 32v equals 0. Divide by 32. And I get v equals 0. That is a solution. So that's one solution, and the solution is b equals 0. Okay, nothing to simplify on this first side. And on the second side, negative 7 times p is a negative 7p. Negative 7 times a negative 5, negative times a negative is a positive. 7 times 5 is 35. There's a p on both sides. We don't like that. I'll choose to get rid of this one. The opposite of a negative 7p is a positive 7p. So I do positive 7p on both sides. Well, negative 7p plus 7p is 0, so I literally write nothing down. Negative 7p plus 7p is 0, so I just cross it off. There's nothing there. And now I end up with 36 equals 35. Well, we might think, well, that's really close. No, it's still no solution, because that means there is no number that I could put here and put the same number here and actually get an equation that works. So no solution for that one. Okay. 30 plus 6p, nothing to combine there or distribute or anything. 7 times p is 7p. 7 times a positive 6 is a positive 42. And then we just have minus 5. There's nothing, this is not in the parentheses, so it just stays as minus 5. So now we can combine 42 minus 5 to get 7p plus 42, 41, 40, 39, 38, 37 equals 30 plus 6p. There's a p on both sides. I don't like that. I'm going to choose to get rid of the 6p because it's smaller than 7. The opposite of a plus 6p is a minus 6p. 6 minus 6 is 0, so I don't have to write anything. 30 equals 7 minus 6 is 1. And I can just write p. I don't have to write the 1 in front of it. Plus 37. Subtract 37 on both sides. And I get that negative 7 equals p. So that's one solution. Okay, we'll make this the last whiteboard question that I show you how to solve. Negative 4 times v is a negative 4v. Negative 4 times a positive 3 is a negative 12. Nothing to simplify on the other side. Now I'm going to point out, they're not in the same order, but this has a negative 4v, and this has a negative 4v. This has a negative 12, and this also has a negative 12. Okay, there's a negative 4v on both sides. We don't want to have a v on both sides, so I'm going to do the opposite of a negative 4v, which is a positive 4v. Negative 4v plus 4v equals 0. So we just have negative 12 equals negative 12. Is it true that negative 12 equals negative 12? Yes. So we have infinitely many solutions. That means there are infinitely many numbers. Any number, any real number will work, as long as you put the same number here as you put in here. Okay, I'll just slowly show you. If you want to do any more practice, you can solve these on your own. Okay, never mind, there was only one of them. And then some time for Alex homework, and then solving some equations for the exit ticket. Okay, negative 14 minus 8x equals negative 2 times negative 3 is positive 6. Negative 2 times positive 7 is negative 14. There's an x on both sides, and we don't like that. Negative 8 is smaller than positive 6. So I'm going to choose to get rid of the negative 8. The opposite of a negative 8 or a minus 8 is a plus 8x on both sides. And now we have negative 14 equals 14x minus 14. Okay. Plus 14 on both sides. That's going to equal 0. 0 divided by 14, and x equals 0. I have a lot of x equals 0 as the number. Okay, negative times 3 is a negative 3. Negative times a negative is a positive 6b. And I see there's a b on both sides. I don't like that. Subtract 6b on both sides, and we get negative 3 equals 5. That's not possible, so there's no solution. Okay, that was an introduction to the number of solutions in multi-step equations. You got this. Have a great day.